Welcome back to Unit 6. Now that we know the basics of rational expressions, we are going to learn how to multiply and divide them. Let's begin by multiplying these two rational expressions. What we don't want to do is simply multiply the trinomials together in the numerator and the trinomials together in the denominator. While that is not incorrect, we can make our lives a whole lot simpler by first factoring each polynomial separately and dividing out any common factors. Starting with the numerator of the first expression, we find that it factors as x plus 2 times x minus 1. And the denominator of the first expression factors as x minus 5 times x plus 1. The numerator of the second expression factors as x plus 9 times x minus 5. And the denominator factors as x plus 2 times x plus 9. Now we look for common factors in the numerator and the denominator for both expressions. We have an x plus 2 in the numerator and denominator. We have an x minus 5 in both the numerator and denominator, and an x plus 9. This leaves us with only a factor of x minus 1 in the numerator and x plus 1 in the denominator. Let's look at another example. In this example, we will once again start by factoring each polynomial in this expression. 36 minus x squared is a difference of squares, so it factors as 6 plus x times 6 minus x. X squared plus 9x plus 14 factors as x plus 7 times x plus 2. X squared minus 7x minus 18 factors as x minus 9 times x plus 2. And x squared minus 15x plus 54 factors as x minus 9 times x minus 6. Now that we have this completely factored, we look for common factors in the numerator and the denominator. We have common factors of x minus 9 and x plus 2. We also have a pair of opposites, 6 minus x and x minus 6. We know that opposites will simplify to a factor of -1 instead of +1. So when we cross them out, we must remember to leave in a factor of -1. Now this expression simplifies to -6 plus x in the numerator and x plus 7 in the denominator. Let's look at a slightly different example. Here we have two functions, f of x and g of x. They are both rational functions, and we are going to find their product. In order to find the product of f of x and g of x, we need to multiply their formulas or rational expressions together. Now let's see what we can factor. The numerator of f of x, that's x squared plus 13x plus 36, can be factored as x plus 9 times x plus 4. The denominator can be factored as x minus 6 times x plus 3. 6 minus x cannot be factored, so we'll simply write it down. X squared plus 8x plus 16 can be factored as x plus 4 times x plus 4, or two factors of x plus 4. Now we look for common factors in the numerator and denominator. We have an x plus 4 in the numerator that cancels out with one factor of x plus 4 in the denominator. We also have a pair of opposites, x minus 6 and 6 minus x. We can simplify those, leaving us with a factor of -1. Now we write down what's left. We have negative x plus 9 in the numerator and x plus 3 times x plus 4 in the denominator. And that's the product of the functions f and g. Now we switch the conversation from multiplying to dividing, but you'll be glad to know that they are very much the same thing if you recognize that dividing by a fraction is the same thing as multiplying by its reciprocal. That is, if we have the quotient a over b, and we need to divide that by the quotient c over d, this is equivalent to multiplying a over b times d over c, the reciprocal of c over d. Let's try that out with these two rational expressions. We have x squared minus 2x minus 35 divided by x squared minus 15x plus 36, and we want to divide by x squared minus x minus 42 over x squared plus 8x minus 33. But that's equivalent to multiplying by the denominator x squared plus 8x minus 33 divided by the numerator, x squared minus x minus 42. That's the second rational expression's reciprocal, or flipped over. Now we can treat this just like our previous examples. We begin by factoring. X squared minus 2x minus 35 can be factored as x minus 7 times x plus 5. X squared minus 15x plus 36 can be factored as x minus 12 times x minus 3. X squared plus 8x minus 33 can be factored as x plus 11 times x minus 3. And x squared minus x minus 42 can be factored as x minus 7 times x plus 6. Looking for common factors in the numerator and denominator, we can simplify x minus 7 and x minus 3. This leaves us with x plus 5 times x plus 11 in the numerator and x minus 12 times x plus 6 in the denominator. Let's take a look at one last example. In example 5, we are again dividing, but this time we're talking about dividing two rational functions. We want f of x divided by g of x. We know that dividing f of x by g of x is the same as multiplying f of x by the reciprocal of g of x, or 1 over g of x. So instead of dividing, let's multiply 3x squared plus 14x minus 5 divided by 2x squared minus 11x plus 12 by 1 over g of x, or 16 minus x squared divided by x plus 5. Factoring, 3x squared plus 14x minus 5 can be factored as 3x minus 1 times x plus 5. 2x squared minus 11x plus 12 can be factored as 2x minus 3 times x minus 4. 16 minus x squared is the difference of squares, so that can be factored as 4 plus x times 4 minus x. And x plus 5 is prime. It cannot be factored. Looking for common factors, we find that we have an x plus 5 in the numerator and in the denominator. We also have a pair of opposites. We have x minus 4 in the denominator and 4 minus x in the numerator. Simplifying those leaves us with a factor of negative 1. Simplifying, we have negative 3x minus 1 times 4 plus x in the numerator and 2x minus 3 in the denominator. And that will conclude this lecture video on multiplication and division of rational expressions.